Come on, do the boopy noise. There we go. And so, once again, the opener is a separate grade. It's just a few questions. I'll add the extra point onto it. I think this is one of the ones that only gives you 99 points. But in your paper copy that most of you have, let me pull one up so I can time myself with this. There are multiple types of bonds, and we talked about metallic bonds. Metallic bonds are between metals where it has that sea of electrons that sort of cushions the positive metallic ions so that they don't repel. That's what gives metals the ability to be hammered into thin sheets and molded into shape. They're not like clay. Metal's done a little bit differently. We had ionic compounds, which was a metal and a non-metal. We had covalent compounds, were all non-metals. And then we have a specific type of bond called a polar bond. And if something is polar, one part of the atom is going to want to collect more of the electrons on its part. So you have a partial negative, which is where the electrons want to go. You have a partial positive, which is where the electrons want to go away from. The overall compound is neutral. There's just a little section that's a certain amount negative, and there's another section that's equal but opposite amount positive. So it has poles like a magnet, hence the phrase polar bond. And I think I put this on here. I did. So you guys should have this image in Canvas too. This is what happens when hydrogen and fluorine come together to make a compound, which is actually an acid. We'll get into acids later after Thanksgiving break. But the fluorine really wants those electrons. Fluorine is the most electronegative element on the entire periodic table. Remember, the noble gases don't count. It wants all the electrons to itself. It doesn't want to share. Like, it wants them all. And even though this is a covalent compound, it's not ionic, you have a definite negative region. This weird-looking symbol is a Greek letter. Okay? It's not an American English letter. That's why it looks different. It's almost like a D with a curvy tail on the top, which means partial. So we have a partial negative charge with the fluorine, and we have a partial positive charge with the hydrogen, but they're equal and opposite. So the entire compound, the hydrofluoric acid, which is what this is neutral. It's just the fluorine part is a little bit more negative, and the hydrogen part is the opposite, a little bit positive. You just have to know how to read the chart. And you guys should have it on your paper. There is a chart, the back, at the very, very, very bottom, has a bunch of numbers on the periodic table. And if you find the fluorine, it gets a value of 3.98. That is its electronegativity value. And if you find the hydrogen, it has a value of 2.20. The fluorine wants it more. It wants it more by 1.78 if you subtract the two. You're literally subtracting today to figure out, is it ionic? Is it extremely polar? Is it moderately polar? Is it slightly polar covalent? By what that difference is. You just subtract the two values. And I'm not going to make you memorize these numbers. I will give you this chart. That's what the assignment today in Canvas is asking you to do. If there's enough of a difference between them, it's ionic. And then as you go down, you can have slightly polar covalent, moderately polar covalent, or highly polar covalent. It's just, you literally are subtracting these two values. And for those of you that are online, on the paper that you have in Canvas, it's the very last thing on the second page. I'm not going to make you memorize any of that stuff. That's not nice. It's not right. But you do need to, if you have not done so, take a look at set 5 on the elements. Just those 10. We'll do that tomorrow. We will review tomorrow. You guys will have a test on Friday. If you plan on starting your vacation early, it would be very, very wise of you to take care of that test before the break and not try to do it when you come back, because you will forget.
What?
There's a test on Friday.
We have school on Monday, right?
No, we don't. No school on Monday. It's Thanksgiving break next week.
I have an ASAP.
Oh, I thought we had school Monday. I didn't have a game. Hold on.
Oh, no, you may have sports stuff that goes on over the break, but there's no, I mean, unless your coach is asking you to come up here. That I don't know. There's a regular class on Monday.
I won't be in class on Friday.
Well, are you gonna start your vacation early?
I'm taking a test.
Which
ASAP.
test? Oh, well. You have to figure out what to do if you don't finish it by then. Because that's when all of my classes, chemistry and aerospace, they have tests on Friday.
Oh, yeah, we don't have school Monday.
Oh, it's beginning of Thanksgiving break. Like I said, if you have like a game or something and your coach wants you to come up here, that, I don't know.
Yeah, I have a game at 11:15 in the morning.
Your covalent compounds, okay, which makes a molecule, ionic, do not make molecules. Ionic compounds are called formula units, which we abbreviate as FU. It does not mean anything bad. It's formula unit. I abbreviate it as FU. I am not saying a bad word. That's just how we abbreviate it. But here's a giggles like that every year. Ha ha! My teacher said FU. But no, it does not mean like that. But it dependent on the molecular structure. This is a molecule of water down here. This is one that we built with that PET lab, and we've drawn and we drew it out with its molecular structure. But the oxygen has 2 lone pairs of electrons. It's like the Mickey Mouse ears down here on the bottom. If you flip it the other way around. Because there's 2 extra pairs of electrons on there, that side, the oxygen side, is slightly negative. Each hydrogen is half of that negative value, but positive. And since there's 2 of them, it's the same amount of positive as the oxygen is negative. So it equals out to 0. It just has a negative and a positive pole like a magnet. And this is why water, since it's polar, can break apart some ionic compounds. The negative side is attracted to the positive ion. We call that a cation. The negative side is attracted to the positive side is attracted to the negative particle, which we call an anion. So this side, if you put salt in water, this side is trying to pull the chlorine off, which it does. And this side is attracted to the sodium and it pulls it off, which is why ionic compounds in the molten state or in the liquid state conduct electricity. That's all electricity is the controlled motion of negative particles that we call electrons. Am I giving this to him or
Yes.
Okay.
You're getting the what?
I don't know. It doesn't something for me to do or I don't know. It's for you. Some molecules, because it's equally distributed, like carbon tetrachloride, which I haven't taught you how to name these things, but that's the name of that compound. Because the chlorines are perfectly distributed in this particular molecular shape, it doesn't have a distribution of charge. It's equally spread around that carbon molecule. That's called nonpolar. You have a generic area that's negative and a different area that's positive that's polar. Everything is perfectly distributed, like carbon tetrachloride, like carbon tetrafluoride or carbon tetrabromide or carbon tetraiodide. Don't worry, I'll teach you guys how to name these. You guys are probably going to like naming these a lot better than ionics because there's no extra rules. But this structure, everything is equally spread out in this particular geometric pattern, and it's nonpolar. But literally, it's carbon. This is chlorine. There's 4 of them. The prefix 4 is tetra. If you've ever played the game Tetris, you guys have played Tetris. Please tell me. Maybe not on the Nintendo, but on your phone. Y'all recognize the name Tetris, right?
Yes.
They
exactly.
each block had how many little blocks in it? 4. Oh, there's this piece.
Oh,
There's this piece. There's this piece. What's the other pieces? There's this piece.
there's a straight down. Oh, yeah, we got them.
There's this piece. And I remember when Tetris came out on the Nintendo. Hey, I think that's all of them. But they all have
There's
4
one.
little blocks. Did I miss one?
Never mind. You got them.
I mean, there's one that's the other direction, but it's still this piece.
It's in third.
No, but it still had 4 pieces in it. But here's why it was called Tetris. I'm sorry, those of you online, I just drew the Tetris pieces out on the dry erase board. There's Tetra, 1, 2, 3, 4. That's why it was called that. You guys probably have heard the prefix quad for 4, but we don't use quad in chemistry. We use tetra. Let's see here. If there are no lone pairs of electrons anywhere, it should be nonpolar. That specific region of electrons, that's normally what causes polarity. If your satellites, okay, so the things on the outside, if they're all the same, those tend to be nonpolar. So like this was carbon tetrachloride. And if I replace the chlorines with bromine, that would be carbon tetrabromide. I'm so sorry, those of you online. I'm not even going to try to draw on my board because we all know what happens when I try to draw on my board. Doesn't work right. I don't even see the Smart Ink tab. Even though I restarted my computer. I do not see my Smart Ink tab. Board drives me insane. But if this is true, then you're not going to have a separation of charge. And if there's not a separation of charge, then it's nonpolar. There is a separation of charge, then it is polar. We're going to fill out, and I hope I didn't make a boo-boo, electronegativity difference type of bond. All right, so we're looking at this chart. If when you subtract the numbers that are in that periodic table at the bottom of your paper, if it's between 0 and 0.39, it is nonpolar. Okay, it's like the carbon tetrachloride. Doesn't have a region of positive and negative. If it's between 0.4 to 0.99, it is moderately polar covalent. It's from 1 up to 2, but not including 2. Then that's highly polar covalent. And if it's above 2, it's ionic. And you guys should have had this filled in on your paper because I'm looking at it right now. We're going to, using that chart at the bottom, we're going to figure out if the hydrofluoric acid, what it is, the sodium chloride, and the bromine molecule. What is the difference in the electronegativity? And then according to this, which I gave to you, which one of these is it? So first one, HF. What is the number for hydrogen? 2.20. What's the number for fluorine? The F. On the right hand side.
3.98.
Okay, so subtract them. 3.98 minus 2.20. Do y'all see where I'm getting these from? Look.
No.
Oh, yeah.
Hydrogen is 2.20. Fluorine is 3.98. When you subtract them, it is 1.78. I'm going to share the way that my screen is showing to you guys online because I just heard, I don't know where I'm getting it from. Let me stop and let me share my screen. Okay, so on your paper, down here at the bottom, hydrogen is 2.20. I'm not going to make you memorize this chart. So the assignment that's today, you're doing this. You're finding the elements, you're subtracting them, and then you're comparing that number to this chart. Which one is it? So hydrogen is 2.20. Okay, the fluorine is 3.98. If I go back to this, so 3.98 minus 2.20 is 1.78. So what type is it? If this is your difference, which of these is hydrofluoric acid? You're highly polar covalent because it falls in right here. That's literally what your assignment is today. You're looking at this chart. Sorry, I'm going back and forth. You're looking at this chart. Subtract the smaller one from the bigger one. The difference, I don't want to know negative numbers. What's the difference? And then you're going to compare that value to this chart, and it's going to tell you which of those four it is. So in the second one we're going to do, oops, you guys don't want to do rocks. All right, sodium chloride. I'm going to do rocks, huh? My geodes came in. We're going to start popping geodes tomorrow. So we have sodium and chlorine. Yeah, sodium is 0.93. Chlorine is 3.16. That's where I got those from. And when I subtract them, I get 2.23. What type of a compound is sodium chloride? It is ionic. Okay, so If the first thing that you have is a metal, it's going to be ionic. Okay, if this number is not above 2 or above 2, then you probably looked up the wrong element. If they're all non-metals, including the bromine, then it's one of the types of covalents. Now, if it's the same element, what's anything minus itself? 2.96 minus 2.96, what is it? 0. So this is what is called non-polar covalent. It is a non-polar molecule. So this is seriously what you are doing on your assignment. You're going back and forth, and I put in Canvas, okay, I've learned how to use a snipping tool properly because that's what Canvas likes. What I did was I took this image, okay, and I embedded it into your Canvas assignment. So you have this on every single one. So you don't have to go back and forth, but you're going to subtract, just do the larger one minus the smaller one. What is the numerical value? I don't think I made any boo-boos putting this in. And then you're going to pair whatever the correct answer is, you're going to compare to this chart, what type of a compound is it? And that's seriously what you're doing. And you should be able to finish. We have 20 minutes left in class. You really should be able to do this, no problem. I'm going to stop the recording.